Hello everyone. Let's have a look at a second method. So this one we're not using algebra. We are going to have a go at a different way. So a quadratic sequence question. Same question as previous clip. For first five terms of a quadratic sequence, 1, 3, 7, 13, and 21, we want to find an expression in terms of n for the nth term of the sequence. So both methods start in exactly the same way. Just going to copy my sequence again. So 1, 3, 7, 13, and 21. And both methods start in the same way, as we were saying. So I work out my first difference, 2, 4, 6, and 8. And this is how I know that I'm going to have a quadratic nth term. So my nth term is going to contain a square n in it, because the first difference is not always the same. And let's check the second difference. So in this case it's 2. Of course the second difference has to be the same. So in this method, once you worked out your second difference, divided by 2. So second difference divided by 2. So your second difference in this question is 2 divided by 2, and that is just 1. Once you've done this very important step, which many people forget to do, you stick an n squared to it. So what this is telling me to do, this 1n squared, is telling me that I should write my square numbers. So that's what I'm going to do. First of all, I'm going to do a little bit of labeling so you understand what's happening to you and to this question in general. So this is your sequence. And this is your n squared, so your square numbers. And I've got 1, 4, 9, 16, 25, so on and so forth. Next step we want to do is we want to work out what's the difference between the sequence and the square numbers. So we're going to do sequence minus the square numbers that we just wrote. So 1 take away 1 is 0. 3 take away 4 is minus 1. 7 take away 9 is minus 2. And then we've got minus 3 and minus 4. So you might notice that we've got a linear sequence now. And thankfully for us, we've hopefully been practicing linear sequences as well, working out the nth term. We're going to work out the nth term for this. So this sequence is going down in ones. So I write that down and I stick an n to it. And then I'm looking for that 0 term. So going with my sequence, I take away 1 always. And going back, I'm going to have to add 1. And I end up on positive 1. So plus 1. Now these two things have to come together. So I take my n squares, so n squares, and then my linear nth term that I just figured out, which is minus n plus 1. Obviously the same answer as in the previous method, otherwise it would have been a little bit awkward. So you watch both methods and make a decision which one you're happier with, and then go for that.